This research paper addresses the critical issue of enhancing both individual-level and system-level diversity in industrial recommender systems, specifically focusing on WeChat Feed Recommender. The authors contend that graph-based retrieval strategies often favor heavy users and popular items, leading to a lack of system-level diversity. Meanwhile, Determinantal Point Process (DPP) is commonly used to increase individual-level diversity but relies heavily on semantic information of items and suffers from clickbait and inaccurate attributes. To address these limitations, the authors propose an integrated solution that incorporates retrieval graph information in diversity-based reranking to weaken the hidden similarity of items exposed to users, thereby improving system-level diversity. They also argue that users' propensity for diversity changes over time in content feed recommendation, and suggest capturing the user's real-time personalized propensity to diversity using the explored graph. The combined system was implemented and deployed in WeChat app's top stories, used by hundreds of millions of users. Offline simulations and online A/B tests demonstrate that the proposed solution can effectively improve both user engagement and system revenue. This paper emphasizes the importance of considering both individual-level and system-level diversity in industrial recommender systems, providing an efficient and deployable solution for web-scale recommenders. It also highlights the mutual influence among different stages in real recommender systems and the need to address the limitations of existing approaches that focus on only one level of diversity. The text emphasizes the significance of both individual-level and system-level diversity in content feed recommenders. It underscores the limitations of existing methods, particularly their reliance on semantic information and the inability to accurately consider category information. The authors propose an end-to-end diversification framework that leverages graph exploration to enhance both individual-level and system-level diversity. This framework comprises graph-based embedding retrieval, ranking, and reranking stages to ensure a personalized and diverse feed for users. The authors also stress the necessity for real-time user behavior analysis to adjust diversity parameters dynamically. The paper highlights the significance of both individual-level and system-level diversity in recommendation systems, focusing on enhancing these aspects through the use of graph neural networks, GNNs, and diversified reranking techniques. Most current methods concentrate on either individual-level or system-level diversity separately, but this approach integrates both levels into a single solution. In the retrieval stage, GNN-based models, specifically GraphSage, are employed to generate item embeddings for unseen nodes efficiently. This method samples neighbors of a node, aggregates neighborhood embeddings to update node representations, and uses item attributes as node features. Random walk is adopted to sample neighbors of each node, and unsupervised GraphSage is used to generate the embeddings of all items. The paper also emphasizes the importance of real-time personalized determinantal point process (DPP) in the reranking stage to capture the user's real-time preference for diversity. A subgraph with the best trade-off between relevance and diversity is generated, and the path is explored by real-world users. These graph explorations are then merged in the huge item-item graph to increase the system-level diversity. This paper presents a novel idea of viewing individual-level and system-level diversity as an integrated problem, and attempts to solve it in a simple yet effective solution. It leverages the item-item graph embedding in the retrieval stage to capture the user's real-time preference to diversity, reveals the interactive similarity of ranked items in the reranking stage, and increases the system-level diversity by merging graph explorations in the huge item-item graph. The integration of the retrieval and reranking stages in the proposed solution focuses on two levels of diversity. This includes the concept of real-time personalization, capturing user preferences dynamically. The proposed framework enhances both individual-level and system-level diversity in content feed recommendation systems by utilizing graph-based retrieval and reranking techniques. It consists of three stages: retrieval, reranking, and real-time deployment. In the retrieval stage, a graph-based model generates candidate items highly relevant to user interests, trained using real-time user feedback and item features. This adaptability to changing user preferences is crucial for improving recommendation accuracy. The paper emphasizes the dual significance of individual-level and system-level diversity in recommendation systems, demonstrating how these two aspects interact across different stages of the system. It introduces a novel framework that reuses graph exploration throughout various phases of the recommender, leading to consistent enhancements in short-term, long-term, and commercial benefits. This proposed method incorporates a real-time personalization strategy to balance relevance and diversity, making it efficient and deployable for industrial recommenders. Improving diversity in recommender systems is crucial to enhance user experience and mitigate the echo chamber effect. The WeChat Feed Recommender, a prominent social media platform, faces similar challenges. This study explores various methods to enhance both individual-level and system-level diversity in the WeChat Feed Recommender. At the individual level, diversity is critical to provide users with a diverse set of recommendations, reducing the likelihood of repetitive content. To achieve this, the authors employ a multi-objective optimization framework, incorporating both accuracy and diversity metrics. Specifically, they utilize a weighted sum method to balance the two objectives, ensuring that the model prioritizes diverse recommendations without compromising accuracy. At the system level, diversity is essential to cater to the diverse interests of the entire user base. The researchers propose a novel framework, dubbed diverse exposure, which aims to maximize the aggregate diversity of recommendations across all users. This is achieved by optimizing a global diversity metric, which encourages the model to explore diverse topics and reduce redundancy. The authors also investigate the effectiveness of incorporating knowledge graph-based features into the recommender model. By leveraging knowledge graphs, the model can capture complex relationships between items, leading to more informed and diverse recommendations. Experimental results demonstrate the efficacy of the proposed methods, with significant improvements in both individual-level and system-level diversity. The study highlights the importance of balancing accuracy and diversity in recommender systems, providing insights for future work in this area. Graph neural networks have emerged as a promising approach in recommendation systems, enabling personalized recommendations by modeling complex user-item interactions. Recent studies have focused on improving recommendation diversity, accuracy, and personalization using graph neural networks. The Neural Graph Collaborative Filtering model, for instance, integrates graph neural networks with collaborative filtering to enhance recommendation accuracy. This approach leverages the strengths of both methods, capturing complex user-item relationships and incorporating neighborhood information to generate personalized recommendations. Another notable study employs graph convolutional neural networks for web-scale recommender systems, demonstrating the scalability and efficiency of graph neural networks in handling large-scale user-item interaction data. This approach facilitates the learning of rich item representations, leading to improved recommendation accuracy and diversity. To further enhance recommendation diversity, researchers have explored diversification techniques, such as maximizing the aggregate diversity of recommended items or incorporating diversity regularized loss functions. These strategies aim to provide users with a diverse set of personalized recommendations, reducing the likelihood of repetitive or redundant suggestions. The incorporation of graph neural networks has also been shown to improve recommendation accuracy by modeling complex relationships between users and items. By capturing these relationships, graph neural networks can identify subtle patterns and preferences, leading to more accurate and personalized recommendations. Overall, the integration of graph neural networks and diversification techniques has the potential to significantly enhance the performance of recommendation systems, providing users with more accurate, diverse, and personalized recommendations.